Okay, so this video will be a little bit more difficult to shoot because of this little fella. She just cannot shut up while I'm talking, so yeah. Hi guys, welcome in another video, and today we will talk about memory consumption. I think when we are thinking about out-of-memory errors, the first thing that comes to mind are memory leaks. And this reasoning is of course correct, but we can still get out-of-memory errors even if there are no leaks in our code. And it's just because our app uses too much memory. If you are working on an app that loads a lot of images, the thing that can highly elevate your memory consumptions are bitmaps. And that's why in this video I want to talk to you about how to measure how big are bitmaps that are stored in your memory and how to optimize them while using two most popular image loading libraries, Glide and Picasso. So let's begin. The common misconception that I sometimes encounter is that the size of the bitmap that is stored in the memory is always the same as the size of a file that you download from the server, or at least that the dimensions of the bitmap are always the same as the image that you fetched. But it does not necessarily have to be always true. To find out how big are bitmaps stored in the memory, the easiest way is to just measure it using Profiler. In Profiler, we can make a snapshot of memory used in any given time, a heap dump, and find out how many bitmaps are loaded and how big are those bitmaps. As you can see, in this simple demo app, I have a few bitmaps loaded. Here is a preview of a bitmap, and here you can see a size in bytes that this bitmap takes. And some quick tip for you here. If you want to inspect bitmaps in memory, it's good to do it on a device or an emulator with an Android 7.1 or lower. Android 7.1 is the last version that allows us to see bitmap preview in Profiler. And this feature is extremely convenient when working with bitmaps. In version 8, there was a change implemented in bitmap class that made rendering bitmap preview in Profiler impossible. The size of the bitmap that is stored in the memory depends on two factors: the quality that you use to create that bitmap and the bitmap dimensions. And those bitmap dimensions are determined differently depending on which image loading library you use. So how exactly Glide and Picasso determine the bitmap dimensions? In Picasso, the dimensions of a bitmap are the same as the dimensions of an image that you downloaded. So it doesn't matter if your view is only, let's say, 200 pixels square. If you load a very huge bitmap into that view, for example, an image that is 1000 pixels square, the size of that bitmap will be 1000 times 1000 times 4 bytes, so about 3.8 megabytes. So if you are using Picasso, it definitely pays off to download images that have similar dimensions to the views. Not only because images that are bigger in general take longer to download from the server, but also if you are using Picasso, those huge images can elevate your memory consumption, and that can lead to out-of-memory errors, especially on some low-end devices that have less memory available. Glide, on the other hand, has a completely different approach. If you are using Glide and load a 1000 pixel image into a 200 pixel view, the bitmap size will be only 200 times 200 times 4 bytes, so only about 0.15 megabytes. Of course, you still shouldn't load such a big image into such a small view, because download time will be very, very long, but if you absolutely have to do it, in Glide at least you get a better memory footprint, since bitmap will take much less space than if you were using Picasso. But what if you are already using Picasso and want to achieve similar results? As it turns out, it is possible. Picasso library contains several functions that allow us to achieve similar behavior that you know from Glide. I think the most useful of those functions is fit. When you are using fit function, Picasso, before it creates a bitmap, it will first measure your view and only then create a bitmap that have the same dimensions than the view. So Picasso with this function behaves the same as Glide. Okay, so now we know how big are bitmaps created by Glide and how to configure Picasso to behave the same way. But is this behavior always giving us the optimal result? Well, there's one case when the bitmap created using that strategy will be bigger than created in Picasso by default. Let's say that to optimize memory consumption on some low-end devices, we decided to fetch images from the server that are 20% smaller than our views. So, for example, into a view that is 200 pixel, we want to fetch an image that is 160 pixel and then stretch it and put it into our view. It might be surprising, but in this case, Glide will create the same bitmap as we were loading image that is 200 pixel or 1000 pixel. Why? Because Glide always creates bitmaps that have dimensions the same as the dimensions of the view. But we can easily fix that by using center inside function. And this function always seemed for me a little bit uninteresting because I never thought that it has any impact on memory, but as it turns out, it causes that our bitmap dimensions will never exceed the dimensions of the original image that we fetched from the server. So loading an 160 pixel image into 200 pixel view with center inside creates only 0.1 megabyte bitmap. Everything looks the same as when we were using default options, and for images that are smaller than views, we got lower memory usage. Okay, enough about bitmap dimensions. What about the other factor that influences bitmap size, the quality? Both Glide and Picasso use the same image quality by default, ARGB 8888. In this quality, it takes 4 bytes to encode 1 pixel. That's why in all my previous calculations, I multiplied bitmap dimensions by 4 bytes. But we can very easily change that in both Glide and Picasso and use different quality, RGB 565. In this quality, it only takes 2 bytes to encode 1 pixel. So if we use that quality, our bitmaps will be 50% smaller than if we were using the default quality. Of course, if we use RGB 565 quality, some images may look a bit worse. This can be especially visible on gradients, but as you can see on that comparison, it's not that bad. But really important thing, RGB 565 does not support alpha. So you should use ARGB quality if you need to load images that are transparent or partially transparent. I think if you want to quickly get rid of some out-of-memory errors, the good strategy may be to use lower bitmap quality for low-end devices. You can determine at startup how much RAM the device has and which version of Android it uses, and then determine which image quality to use. Of course, you should only use RGB quality for images that do not need alpha. And for other, more powerful devices, when there is no problem with out-of-memory errors, you can use standard ARGB 8888 quality to not decrease user experience without need. Okay guys, so that's all for today's video. I hope the information that I gave you here will help you to get rid of some nasty out-of-memory errors. And if you want to learn more, I also created an article on how to optimize memory consumption in Glide, and I go even more in depth in that topic in this article. So if you're interested, definitely check it out. The link is in the description. Also, if you want to watch more videos like this, hit the subscribe button. I'll create more videos targeted for experienced Android developers really soon. So stay tuned. We'll see each other in the next video.